or at least the most sense. So let's look at number one. I'm going to show you, well, I'll go through number one by hand, and then I'll show you all the nice little shortcuts related to this. You're mostly, I think, all familiar with the concepts of PEMDAS or GEMA. All right, so parentheses, exponents, multiplication, division, addition, subtraction, or grouping exponents, multiplication, addition. All right, I'm a PEMDAS fan, but that's only because that's what I learned when I was growing up. So, you know, it's just more out of habit than out of personal preference. I'm sure if I learned GEMA first, that would be my preference, but I didn't, so it's not. All right, so in number one, I don't see any parentheses. I don't see any exponents. I do see some multiplication and division, but when you see multiplication division, you do it in the order of left to right. So I'm going to handle this division part of the process first. All right, 24 divided by 6 is 4. Then I'll handle this division component, negative 48 divided by 6, 8, negative 8. And then I'll handle this multiplication. So negative 8 times 8 is negative 64. So we have the 4 plus 4 minus 64. All right, so in order of left to right, again, for addition, subtraction, 4 plus 4 is, minus 64 is, negative 56. That seemed like what most people were getting? Yeah. Okay. Now, the calculator is programmed to understand order of operations. So what that means is, as well as you think you know order of operations, the calculator knows it better, right? Because the calculator is defined by order of operations, all right? So I'm just trying to think of something that you would naturally know better than some inanimate object or someone who's not a human, like feeling. Like having emotions. If you were to compare knowledge of emotions to that of a calculator, and the calculator tried to tell you how to feel, you'd be like, we're pre-programmed with emotions, you're not. So it's actually sad. Because now I think of like all those AI movies and how they all evolve to have feelings. And it's all such a load of bull. They could never. Poor things. Anyway, so what that means is that if I type in the expression exactly the way I see it on paper, then the calculator is going to follow the proper order of operations and spit out the correct answer. The only thing is, when I hit the division key, it's going to bring up the slash, but I'll get over that very quickly. Just double check Aruski here. All right, moment of truth. Oh, would you look at that? That's just crazy. In one line, without me doing any work whatsoever, it computed the final answer, and I didn't have to do any thinking. That's incredible. And you know what? I lied. I said that I would just do the first one, and then I'd show you the shortcuts, and that would be the end of it. I want to do the second one also because it's a little bit more complicated. Parentheses first. So 4 minus 2 is 2. We're still living within parentheses. Now, just because it's a square set of parentheses or brackets doesn't mean that it's not parentheses. So we're still inside, we're tackling that expression. Within the parentheses, we have an exponential expression. So we'll tackle that. So that's going to become a 4. All right. So still in the parentheses, negative 5 times 4, negative 20. Minus a negative is positive, so we're going to distribute that negative. So 10 plus 20 30. All right, so let's see how the calculator would handle this. So I wanted to go over definitely this one because the calculator doesn't have the square brackets installed in it the way that we would understand them. They have it, but it's for something else. So we just use regular parentheses a second time. Right, so 10 minus open paren, then negative sign. It's really frustrating that these are, as far as I know, the only graphing calculators in the market that have one key for a negative sign and a completely unique key for a minus sign. Every other computing technology understands that a minus means one thing in one situation and another thing in another situation. But this calculator can't handle that, so that's two separate keys. So you just got to be careful. Open paren, 4 minus 2, close it up, square it, close it up again. Wah, wah, wah. I missed a 5. Okay. Second, enter to recall the previous line. That's one way to do it. Another way to handle it would be to go up and hit enter on your previous calculation so that you don't have to retype the whole thing. All right. Now, I just need to insert a little 5 in there. What function on my calculator do you think I might want to use if I want to insert a 5? Take a guess. If I want to insert a 5, what function do you think I might want to use? Insert. Oh, wow, good stuff. All right. So the insert key. Oh, man, now that I moved myself, I'm blocking the poster. That really is unfortunate. But I'm not going to get up. But it's right here. I hit my head. It's right here. Second delete. All right. Second delete. So you go on to the open set of paren, right? The thing that you want to shift over, and hit second delete. That's insert. And then just type that little 5 in there, and then hit the right arrow to get out of that function, and we have what we need. All right. In this case, you might not think it's a valuable function because you'd be like, I could just retype the whole thing. You'll get later in the course and you'll type like an entire line of mathematics, and you're going to be like, I just missed a negative sign. I don't want to have to type this whole thing again. So this function will be really useful in that regard. And there it is, the 30. We got it. I knew it was there. It was there the whole time. All right. So look at this baby. Pretty beefy. However, I don't have to do any thinking because I can just type it in as is. However, as I learned in the last problem, if I don't type it in correctly, all bets are off, but I think that's probably common sense. So open paren, 24 minus 3 cubed. All right, that little caret symbol. So I'm going to move this tomorrow or after class today. But that little caret symbol, the triangular upward jammy, hit that. That gives you the exponent function. Put in the 3. Right arrow to get out of it. Divided by 9 times 7. Close the paren. Caret 4. Right arrow to get out of it. Minus 6. Squared. You can use the squared key again now. Divided by 4 plus 2 caret 3. All right, so if you're confident that you typed it in, and I'm pretty bold, I don't even check my work, hit enter, and you get 80. Hopefully that is what you got when you did it. All right. My philosophy on certain things, I mean, rote computation, that's like when you do just calculation for the sake of calculation. I don't really feel the need to assess you on that because I feel like you've been assessed on that all throughout middle school, right? Like just your ability to do things without calculators and stuff like that. So now is an opportunity to expand upon that knowledge base, but I don't want you to be hindered by ability or inability in the realm of mental math. So we'll be focusing on strengthening your mental math ability throughout the year, but it won't be something that'll count against you. All right, so it won't work against you if you've been a little iffy in that department. All right, so the calculator's there to support you. I always encourage you to try doing something by hand, try doing something in your head first, and then do it on the calculator. But I always have my mind on the fact that at the end of this course, you're taking a Regents exam, and on that Regents exam, you have one goal: to get stuff right, okay? And so when you see a question like this, and it's got 4 choices, multiple choice question, are you going to do all the work like we did in numbers 1 and 2 and waste all that time? No. You're going to pop it right in your calculator, hit enter, circle the answer, and move on to the next question. All right. Now, numbers 1 through 4 in the next section, those are a little iffier because you can't really just pop it into the calculator and call it a day. So what we need to do is, well, the directions make it clear what we need to do. Insert parentheses to make the statement true. But what we want to do specifically is figure out where those parentheses ought to go in order to make that statement true, which means PEMDAS is still in play, or GMA. It's supposed to be 85 degrees today. It's going to suck. I'm going to preemptively put the fan on because I'm already starting to get... It's starting to get a little stuffy.
I have a question.
Go.
How come they give you options for brackets on like this?
What
are those for?
The squiggly brackets?
Yeah.
That's for sets of numbers. That's a different kind of bracket. We'll actually get to that later in the course, but it's not the same kind of thing. Okay. So what we want to do is kind of upset the order of operations. All right, because if we were to follow order of operations here, I could just type in what they have, and you get 16. So the left-hand side is obviously not equal to the right-hand side, all right? And they're saying insert parentheses, because if they didn't say that, if they just said manipulate the equation to make it true, I would just add 1 to the right-hand side and call it a day, all right? But what we want to do is upset the order of operations, because parentheses automatically goes to the front of the line when you're talking about the order of operations. So when I do something like this, I think about what operation I would be doing last. The addition, exactly. And that's where I would try to put my parentheses. And if that doesn't work, then I would think, okay, what operation would I do second to last? I'm going to do order of operations in reverse. All right, so I'm going to put parentheses around these two and see what happens. All right, the good news is, very quick to check. Oh, would you look at that? Now, I got to tell you, in the past, when I've given a quiz or test on involving a question like this, I've had people like done with every other question on the quiz or test, and then spending like 20 minutes on just this one question, because they're putting the parentheses in, and then they're trying to work it out by hand. Then inevitably they make a mistake because they're nervous, and then erase everything, and then go back, try putting the parentheses somewhere else, work it out by hand, and so on. Right? The calculator is your best friend when it comes to this. Put the parentheses in, then run it through the calculator and see what you get. All right? We know that 15 is equal to 15, and this baby checks out. All right? So I could do more, but I'd rather you play around with this type of problem on your own. It's better if you experience them than for me to just give it away. But I do want to do number 5 with you really quickly, because it's the weirdest one, I think, out of all of them. And then you'll be off to the races. All right, so use the order of operations and the digits 2, 4, 6, and 8 to create an expression with a value of 2. So the answer has to be equal to 2. You may add exponents and or negative values as needed. All right. Now, I will say, and this is not for the purpose of like making you think highly of me or not, or just like not think less of me. Any weird questions, like ones that are like, why do we have to do this kind of question? I promise you, it's because some variation of that question was on a Regents exam at some point. All right. So some of these questions are, I think, interesting to do just for fun. But if I had a choice, I wouldn't put them on a test because I think they're too open-ended. But they have been on Regents exams before, so that's why we tend to focus on this sort of thing, right? And the explanations and all that stuff. So just so you have that background. All right. So 2, 4, 6, and 8 to create an expression with a value of 2. Now, sometimes you get a little paralysis by analysis here because you look at it and say, okay, where do I start? You may use exponents and or negative values as needed. All right? It doesn't say you can't use other things. All right? So basically it's saying we have all the different order of operations available to us. So let's just do it. But the numbers 2, 4, 6, and 8 have to be in there. So let's just start putting numbers down. How about 4 squared? All right, so I got an exponent. And then how about minus, I'll do some parentheses. I could put anything in those parentheses, but I want to, because 4 squared is going to give me a 16, so I'll keep like a little running log of what I have. I need to subtract something substantial from that 16 in order for this to work. So 2 times 6, okay. All right, so that's going to get me to a 4, and I've used everything except for the 8 at this point. All right, so maybe not that. Maybe let's get the 8 in there. And how about a plus? So if we have 16 and we do an 8 plus 6, what would we have? 14. Oh, so that wouldn't account for the 2, right? Oh. Use order of operations. And only the digits? It didn't say only the digits. It's assumed though, right? I was going to say, because then we could just do plus 2 times 0 and then call it a day, but I guess we could have done that for everything. All right, so that's no good.
Aren't all the digits used though?
Oh, you're right. My bad. It was right in front of my face. I appreciate that. Boom shakalaka is what we say when that sort of thing happens. Yeah, good call. Thanks, man. I appreciate that. Yeah, I neglected. It was right there. It was staring me right in the face, the 2 that I was trying to subtract or add on. It was right there. It was there the whole time. So